Hello, hello. Welcome to my new interview series with OpenTelemetry luminaries and contributors. I'm here today with Reiley Yang from Microsoft. Reiley, why don't you introduce yourself and explain your role in the OpenTelemetry project?
Yeah, thanks, Ted, for having me here. So I'm Reiley. I've been in Microsoft for 10 years, and I started working on the OpenTelemetry, even before that on the trace context spec and open census. And with Ted 3 years ago, so I've been on this project since the ever beginning of the OpenTelemetry. And now I'm working on the metrics part. Thanks to everyone.
Yeah. And you got involved, I know, because Microsoft was interested in OpenTelemetry and observability. I'm curious, like what was the motivating factor there for Microsoft?
Okay, so I can talk about the overall thing or a specific trigger. I will start from the overall thing. Like Microsoft has a lot of like very like long period products like Windows, Office, those things. We also have the like relatively newer like offerings like Azure and those subscriptions and Xbox game and a lot of cool stuff. And all the products we have are built on top of telemetry. We need to understand the problem, the usage that help us to fix problem. So the very initial thing, probably people heard about like blue screen in Windows. That's actually like the blue screen we caught a particular hardware manufacturer or the vendor, they could have malfunctioning like components, and we'll collect them like back to Microsoft so we can bucketize them to see who's the faulty part. And the first time when I initially heard that 70% of the blue screen of death was not caused by Microsoft code. It was either the hardware is completely broken or the third-party vendor driver is broken. And you can see like by understanding that we can bring better software to our customers. So for OpenTelemetry specifically, I think the trigger is for distributed tracing because historically this company, like Microsoft, has been doing the telemetry for many decades. But as we're seeing more and more microservices coming, I think there are three things we were facing the challenge or the opportunity. Number one is it's no longer a single company trying to bring the entire solution. Like people, they might build something running in their on-premise environment, and then they communicate with the cloud. And they might have other services or different providers building their stuff in a different cloud. Even in Microsoft, we have the situation where some of the Office services are running in a specific data center, but they have to interact with Azure, and there's some regulation problem. They cannot sit together. So how do we have those services, and especially those services are not owned by a single company? Being able to coordinate, especially on distributed tracing, is a hard topic. And historically, many folks in Microsoft invented distributed tracing protocol. And for me, like I've been in Microsoft for 10 years, and I even invented 2 protocols. So you can imagine, like we have almost like 20, if not more, protocols. So how do we converge them? And also, instead of inventing yet another Microsoft protocol, but try to be a better citizen aligned with the industry. And more importantly, we can contribute our expertise back to the industry. Is the trigger that we started to invest in open census and later became OpenTelemetry.
Yeah, so that's really interesting. So it sounds like for some companies, they're interested in OpenTelemetry because they want their users to use OpenTelemetry so they can consume the data. But Microsoft, it sounds like you all actually want OpenTelemetry to instrument your own software, including big flagship stuff like Office, because you have just like a smorgasbord of telemetry tools, and you want to standardize on something that's more like a public standard.
Yeah. So the main business challenge we're facing is we're not building the very end product as the only offering. As a company, we have platform, and if people look at the product Microsoft offers, a lot of them would give people extensibility, or they even allow people to use a framework and build something on top of that. So the great example I can give is .NET. If people use the .NET runtime, they might have already been using a lot of like components like ASP.NET and those components. with those components, leveraging OpenTelemetry and giving a standard, like the industry standard tracing experience and all the built-in telemetry would be a big plus for the .NET, the entire ecosystem. And thinking about the service, if people look at Azure, there are 3 types of telemetry data. One is the telemetry data that the user collects and they send to their place, whether that place is something like Azure Monitor, or it could be on AWS, Lightstep, whatever vendor system. And the second category is the telemetry that Microsoft collects, but we need to send that to the customer. Like, hey, run something on the Microsoft provided VM, but you're the owner of that VM, you pay for the VM. We should give you visibilities, all the VM infrastructure logs, all the operational information, metrics, those things. But those are relatively easier. If you think about the high density service, we have like Azure Storage Blob, where a single server in the storage team, they might be serving like thousands of customers, and they have to send specific information like audit logs to a particular customer. Well, running on that machine, there are many customers. They cannot send this customer's audit log to another customer. So it's a multi-tenancy issue. And also they have their own operational data. And being able to correlate them and how to demultiplex, those are like a very specific challenge for Microsoft. That's why we try to think about them holistically instead of trying to isolate them based on whether it's Microsoft internal or external. And also, when we look at the trend, I think a lot of things start to become smoothed out instead of having a physical line drawn between them. So a lot of Microsoft products are actually a collaboration with other companies or with the community, and we have a lot of open source effort. Like .NET runtime itself is open source, and the Dapper microservice architecture itself is open source. So if we are saying if Dapper wants to collect the data, I think probably for Microsoft data, we want to still send back to our storage, but it makes sense for other people in the community to use Dapper or .NET runtime to send data to their place instead of like bind everything to Microsoft specific technology. So that's the whole purpose of when we look at OpenTelemetry. It gives us a big opportunity of being able to have a very consistent solution for all our different needs. And also, you probably saw the blog from GitHub. I think after they got acquired by Microsoft, they're facing similar problem. Their regulation, we have a high bar or like a very like critical promise for the customers to keep data compliance and transparency, like security. So some of the GitHub offering will have to have a specific Microsoft version in order to meet that standard. But most of the GitHub.com will stay relatively vendor agnostic. So those unique challenges bring GitHub to believe OpenTelemetry is a solution that helps them to solve 3 different type of problems as a single offering.
Yeah, that's awesome. And it's kind of cool to think about the fact that OpenTelemetry might end up in some real staid pieces of software like Office and Xbox. That'd be really cool if that happened.
Yeah, it will be step by step. Some of the box software, we have a lot of like legacy problems, and also the product life cycle is very long. Like Windows Office, they're like at least 10 years. Some of them could be 20 years. So I wouldn't expect all of a sudden like we just rush in and start to change. But over time, I can see those products will start to leverage more and more this great technology, and just to help us to build better product and better ecosystem and bring the value to our end user.
Yeah, and that's why we're so obsessive about stability in OpenTelemetry, as we see that kind of product lifecycle coming at us. So the decisions we're making this year are decisions we're going to be living with like 20 years from now, literally. So that's why we want to be careful with it. Which maybe leads to the next topic, which are your contributions to OpenTelemetry. You've championed a number of important issues. What are the kind of like top pieces in your mind that you've worked on?
So I started on the Python SDK, and soon after that, like we hired someone to replace me. So I started to move on to the .NET SDK and the C++ SDK. And at that time, the .NET SDK has been there since the very beginning, but the progress is a little bit slow. And we also have some very challenging timeline issue with the .NET release. So for folks who are not familiar with OpenTelemetry.NET, it's a little bit different from the other language 6 so far, because we're taking some of the API design and put that as part of the .NET runtime with the hope that it's not just the .NET applications can use those API, but also like some critical runtime like ASP.NET, those part of the .NET ecosystem can take a bet on the system. And also you can imagine like metrics, probably even the garbage collector or the JIT compiler itself can use the metrics API. So we're setting this as a very, very foundation, like a cornerstone of the runtime and taking it seriously. For C++, it's mainly at the time, most of the folks are focusing on the microservice, and it's a little bit weird for people to use C++ to develop a microservice unless you're working on some financial company or stock exchange where you require like nanoseconds latency. So not a lot of people are interested at that moment to spend a lot of effort on C++. But we do see the need of without C++, I kind of worried about some of the design, like especially performance and ABI compat might get ignored. So that's why I champion that project, and currently we're getting more and more attention. So with that, recently I stepped a little bit back from those 6 because they're already well maintained by the other developers. Some of them are from Microsoft and also from other companies. So I started to help out on the metrics API because the part is running a little bit longer than we anticipated. Initially, we were hoping that metrics API can get stable by end of last year. But number one, there are a lot of work on the tracing side, and we kind of having to like put that on delay. The other part is we don't have enough people on the metrics part try to contribute. At that time, we're pretty ambitious. Like this is the first time we're trying to converge multiple projects and also try to correlate traces, logs, metrics, everything all together. And also we're trying to create a separation of the API and the SDK so people can use the API, which is totally decoupled from the actual SDK implementation. So based on this like very ambitious scope and different challenges, we decided to delay the metrics work. And I'm trying to pick it up because I have some background in multiple languages, and we kind of worked with many different companies on this project. So for tracing, I have my connection. Hope that for metrics, I can become a good facilitator. And interesting to say, like I'm not a metrics expert, so I'm more like trying to bring people together and try to ask the right question and also set the timeline so we focus on a concrete deliverable instead of trying to boil the ocean. So more like keeping the balance and doing the like running the community job instead of me trying to be the expert and tell everyone how we can do that.
Which is really the OpenTelemetry way. I feel like there's this way of designing software through a specification that we've developed over time where we want to make sure that OpenTelemetry is going to be stable and also is going to work for everyone. And that requires a lot of input. And when you require that much input, has the engineering chops to understand the design and make their own judgment, but is actually not so much trying to like apply their huge vision, you know, their benevolent dictator vision. What they're trying to do is collect input from all of these important sources and make sure that the final product is gonna work for all of these different people who have different requirements.
100%. I think in OpenTelemetry, you can see the pretty interesting challenge here. We have a lot of folks joining who are from the smaller companies. They're either startup or a specific company that is very deep at the domain. And then there are a few like big companies like AWS, Google, Microsoft. They're working on multiple products, and telemetry, probably cloud is only a sector or a part of their business. And they have different priority and business need. So it's more like smaller companies, they want to move faster and they want to focus on particular thing, get things done. They have a tight schedule. Big companies, they might have something that they consider more, or things tend to be more complex for them. Like the scenario I explained in Azure, the multi-tenancy. And when I talk about the tenancy issue in the OpenTelemetry community, you can see people who are interested. They're like Yana, Josh, they're from Google, AWS, and smaller companies, they like some of them would understand, but normally they don't care too much. So having that balance is critical because we don't want OpenTelemetry to become the solution for smaller scale enterprise, and for bigger one, OpenTelemetry is not the solution. And also we don't want OpenTelemetry to be super complex to be the enterprise solution. So it put a very high bar and it's hard to use. I think we want OpenTelemetry to be easy to get started, but it can be advanced if you want to build extensibility. And keeping that balance is extremely difficult. As Ted mentioned, it requires someone who are not super attached to a particular product. They have to really like abstract it out and stand back a little bit, try to absorb different ideas. But meanwhile, trying to absorb all the ideas and trying to smooth out all the discussion is impossible unless you only have one person in the community. So as more and more people are coming and we start to see like new companies like Grafana Labs joining, and also there are many new folks are reaching out, we start to see the change, and always keep that balance and keep that open discussion, but still being able to make very solid progress has been a very challenging and very rewarding process.
Yeah, and I really saw that in metrics and with your work in it. There was this cycle where, like you said, at the beginning, we were trying to sort of boil the ocean. And at a certain point, we step back and say, well, we're just going too slow. So what we're going to do is just get tracing stable. And this was important anyways, because we needed to think architecturally, how are we going to continue to add features to OpenTelemetry while keeping the stable features from breaking the long-term support guarantees they had? So that was a trick in and of itself, was coming up with an architecture that would allow us to do it. But then intriguingly, announcing 1.0 and getting stable tracing out the door created a new wave of interest. So when we went back to metrics, we realized our original design was good, but too complicated. As you mentioned, it was something that was going to handle all the use cases, but was just like overly confusing for the basic ones. But when we revisited it at that point, suddenly there were a bunch of metrics companies and metrics professionals interested at that point, like Grafana, the Prometheus people. And so suddenly our community grew to include a lot of expertise from the metrics world. And so when you kind of took that project over, there was now this community to kind of coordinate around coming up with an API and an implementation that would be simple enough that end users wouldn't be confused by it, but still ensured we were going to have like the performance guarantees and handle the more complicated issues that we know we were going to have to deal with.
Yeah, so. I remember at that time, like after we released the tracing, we started to have more companies reaching out. And it really helped because like working on metrics, we got feedback not from the companies who have been in OpenTelemetry, Splunk, Lightstep, and New Relic, Dynatrace, Microsoft AWS. Those I've seen like the owner of Micrometer and the folks who are working on the Java like microservice framework like Spring Cloud and Spring Boot, and also folks from VMware and Red Hat. So those are like the fresh blood we bring to the community, and they help us to have a different view. So instead of people who are too familiar with trace trying to define the metrics, to really make sure the people who think about how do we correlate metrics with traces, with that in mind, and also people from Prometheus, they have the background on existing solution, and also people from OpenCensus and other projects who have the prior art like OpenMetrics, and together with people who come in from the user side, their big framework or runtime library trying to adopt metrics, and we bring all the problems together and getting the experts. So it's a Yeah, it's a great thing since the beginning of this year, and really excited to see more and more people are coming. It seems the industry is forming this trend. And
Mm-hmm. And the next bit I see us having to ride herd on, we've talked about this a bit, is there's some siloing going on around, the tracing people think about traces, the metrics people think about metrics, but with OpenTelemetry, we're combining all of that into a single feed, and that's going to enable some really amazing correlations to take place where, when you're emitting metrics, they will have trace exemplars automatically attached to them. So you'll be able to jump from metrics to looking at the trace data that was generating the metrics. But there's some effort we're going to have to put into how the instrumentation works in order to make sure when people start jamming in traces and metrics and all of these things into open source libraries like HTTP clients, that remains like a sane endeavor. Otherwise, you'll end up kind of repeating yourself, where you want to record a request duration as a metric, but you're recording like the duration as part of the trace. So you need to have some way of coordinating between these different instruments.
Yeah. So I think for the instrumentation, there is one key thing that we have to respect the history. So for logging, the great example is instead of trying to invent a new logging API and start to ask everyone to use that, we respect the fact, for example, if people are using Python, Python has the language built-in logging API. It's part of the Python runtime. You just install the Python, you have the logging API. So we believe in most of the cases, there will be millions of libraries that are already using the logging API, and we can not simply ignore them. So being able to provide additional value, like some processor or some log appender, which is something that can enrich the logs to have the correlation ID, will already be very helpful instead of forcing everyone to use. So OpenTelemetry is not something like all or nothing. You must use OpenTelemetry entirely.
Yeah.
We try to be open on this area as well. So for metrics, I think one thing is there are a lot of existing metric solutions. So the famous ones like OpenCensus and the micrometer or like Prometheus client, I think customers should be able to continue to use them until at a certain moment they decided to do some big changes. But we don't have a strong push to force them to change the code because reinstrumentation is hard. With that said, on the other side, I think if people try to use different signals, they have tracing and metrics, like Ted mentioned, it definitely wouldn't make sense for people to describe the same signal 3 times. Like one is a log, another one is trace, yet another one is metrics. So if people look at the existing OpenTelemetry tracing API, you can find something that looks like logging, like the trace add event, like on the span object. This is just for convenience, but there are other scenarios where you start from a logging API, and you can convert that log to an event and attach that to a span. Of course, there's some limitation, different restrictions, but I think the community is heading towards that direction. So you can take one signal and derive different signals from that. So for trace and metrics, I think it's a similar story, but there are some caveats, and I think we're working on the solution. So for tracing, you normally start from a tracer, and when you start and stop something, you have a span which captures the duration, so you don't have to manage the time yourself. And that already removed a lot of hard issue, like people start without stop, or they put the wrong time, something is not monotonic, all the issues.
Yeah.
But when it comes to metrics, normally what people would expect is my metrics should be happening, like the calculation should happen before any sampling. I want all my incoming requests. They might do some filtering. They might say, I don't care about any local access. I only care about the TCP traffic from a particular IP instead of my local loopback. That's fine. But normally people wouldn't say, I only want metrics for 1% of my entire traffic. But for tracing, that's a typical scenario because trace could be more expensive. So having that, I think at a certain point, we might have some higher level thing that can provide the functionality on top of the 3 layers and just move things out. But meanwhile, I still believe those APIs will have this like specifically designed purpose. So you will look at something like ultimately all the telemetry API, they're just p-value pair, you report something, but they give you the performance and a specific tailored scenario just for your case. Like for trace, we start a span, we allow people to add arbitrary information after the span got created. Yeah, you can associate different like attributes. For metric, we're thinking differently because it takes care of the allocation and aggregation and those things. So we require people to provide all the attributes available in one single API call for performance. And later we might say, oh, for metrics, we want to stage that so you can provide all the relatively static information at the beginning and then quickly provide all the remaining thing. So it's all matter of balance. And ultimately, if we're saying the entire OpenTelemetry API is just one API, you report a dictionary, it probably would work mentally, but performance and all the usability would sacrifice. So this is where the balance is coming from. And I think that makes trace and metrics logs separate. That's why we have this concept. But ultimately, from the user, expecting everyone to write 3 lines reporting same data in different form will be crazy. So this is definitely not something we're trying to go.
Yeah, and it definitely seems to be a higher level thing. I really do like that we have an API for each signal and that we designed it so that all of the correlations actually happen under the hood. So that allows you to say, if you already instrumented with Prometheus or something else, Micrometer, if you hook that up to OpenTelemetry, all of those synchronous metrics calls will be getting trace exemplars automatically attached to them. Likewise, with logging, you'll automatically get the trace ID and span ID attached. But then it's just a matter of like on top of that, if you are starting from scratch with OpenTelemetry, how do you prevent just re-instrumenting everything 3 times? And it does seem to be kind of a tricky, it's going to be its own tricky wicket, I think, after we finish the metrics API.
Yeah, and you can imagine like with some language built-in logging API, we might build something on top of that, like a facade. So people want, you want all my data, raw data to go to syslog or something very like high volume, like LTPNG, and still for some of the information I want to derive metrics. I think that's in our scope.
There's also generating metrics after the fact. You can take trace data, which has all of the attributes that you'd want to use as labels on your metrics, and could potentially generate them in the collector or somewhere else if you didn't actually go in there and put a metrics instrument in. But of course, that will have to interact with sampling. And all of that, to my mind, we're seeing sampling as something that's getting pushed out of the process more and more into the collector.
Delay sampling, And those really give you the flexibility because you can change things more dynamically and try to explore the system rather than go back to the instrumentation. So there are pros and cons, and I think it's all depending on the nature of the business. Some of the box software, like the clients, like Windows, once you deploy it, it's very hard for you to add another instrumentation. But you can derive, as long as you have the raw data, you can derive the data from the agent or from the backend.
And something I feel like we've definitely proven out at Lightstep is that the overhead, even for high performance systems, the overhead of having tracing on 100% and sending the data somewhere, 100% of the data to somewhere in your local network is, generally speaking, an acceptable overhead. Like the real hit comes when you start trying to egress that data out of that local network. And I'm sure at Microsoft you have some low-level systems where something like that wouldn't be appropriate. But for the kind of like microservices and internet architecture stuff, high-performance systems like Lyft and Spotify, for example, I feel like those are the kinds of systems that can move to this late sampling model, where you're sending 100% of the data to some kind of processor running in your local network. And then in that processor, the operator has a huge amount of control over what they're going to do.
Yeah, I can see the trend. And this is very similar to the IoT scenario where you have the factories deployed like some edge devices.
Mm-hmm.
They absorb all the information from the factory, like all the sensors, and they get all the access to the raw data. And you can build a very flexible business rule and react quickly. And also the beauty is, even if you don't have network connectivity, either due to internet down or just because you're not available, like sometimes I remember when I was working on IoT, the farmers living like in Texas, and they have huge farms. It doesn't make sense for every single sensor to be able to talk to the very like cloud end. So they can use like Bluetooth low energy or something even lower level like Zigbee to talk and send the data. And after they send data in 1 millisecond, they will switch to deep sleep mode for 15 minutes. And the local data center has the power, sufficient power to handle all the data and making local decision. And that's very efficient. And you only send the data to the cloud if you need some global coordination or something like machine learning where you really need the massive amount of compute power. So there's a balance. It's very similar, like if someone is using a hammer to knock on your knees, you will react, but it's not coming from your brain. It's coming from the nervous system. But every single morning, if you wake up and having every single cell in your body to report the status to your brain, then you will have DDoS attack. You won't be sitting here.
Yeah, I think about this in terms of having written control planes myself. You can look at software-defined networking and like as a place where what you want to do is you want to have like local processing, but you want to be moving the rules down to those local processors and nodes. So so they're able to continue to perform without having to constantly shovel data back to some central data center. But they are networked up into a control plane. So you can control how they're processing data and push out new rule sets based on some kind of feedback loop.
Yeah, and I think in OpenTelemetry, we consider that from the beginning. That's why we pick the name collector instead of calling that an agent, because collector is something you can use the same component to run nearby the machine on the same box or in the same container environment, like the same pod or something. Or you can run it very far away, like on the cloud side. And it's all depending on the configuration. So we're giving that flexibility of the topology to the user.
So if people are listening, there's a bunch of interesting problems still hanging around in OpenTelemetry, right? Like control plane for the collector, more advanced forms of sampling, instrumentation for OSS software, how to dynamically generate metrics from traces. There's a lot of interesting stuff to build on top of this solid base that awesome leaders like Reiley are putting into like the core SDKs and APIs. I think we're at time, but Reiley, I want to thank you for sitting down with me for this interview, and I look forward to seeing you in the next spec meeting.
Yeah, thank you for inviting me and appreciate the opportunity here. So see you later this week. Bye.
See ya.